In this video we're going to look at solving a system of equations by the most useful and popular method, which is by elimination. Please have a look at this first example. It's similar to the burgers and fries from the previous video. Think about what system of equations would model the information contained here. Okay, if B represents the cost of one burger and F represents the cost of one portion of fries, then the first information, his order, would give us 5 times the cost for a burger plus 4 times the cost for fries is $23, and the order he heard from the neighbouring server is 2 times the cost for a burger and 3 times the cost of the fries is $12. Now the important thing to understand is that both of these statements are independently true. So if instead Fred hadn't bought 5 burgers and 4 fries but had bought double that order, then he would have had 10 burgers and 8 fries, and it would have cost $46. Similarly, if the order that he overheard was 5 times that order, so instead of being 2 burgers and 3 fries, it was 10 burgers and 15 fries, then that order would have come to $60. Okay, so Fred's upscaled order is 10 burgers plus 8 fries, which comes to $46, and the overheard order is 10 burgers and 15 fries, which comes to $60. Clearly they both have the same amount of burgers, therefore the fact that there is a different cost must be made up by the fact that there are different numbers of fries. And clearly we can see that this second order has 7 fries more, and that is causing a difference in cost of an extra $14. So if 7 fries are 14, 1 fry must equal $2. And again, we can substitute this information into one of the original expressions. Let's substitute it into this one. If 2 burgers plus 3 fries come to $12, and we know that 1 fries is $2, then the 3 fries here must be $6. So 2 burgers plus 6 must equal 12. So 2 burgers must equal 12 minus 6, which is 6. So 1 burger must equal $3. And 1 fries must equal $2. It's always good to check with the other equation that that still holds true. So if a burger is 3, then 5 burgers would be $15. And if fries are 2, then 4 fries would equal $8, and certainly 15 plus 8 does indeed equal 23. So the solution to this system is that burgers are $3 and fries are $2. So let's use this second example to figure out exactly what we did in the previous one in a more systematic way. 3x plus 7y is 45, 4x plus 5y is 47. They have nothing in common, we can't compare them, so we need to scale them up to either make the x's the same or make the y's the same by looking at the lowest common multiple of those, or indeed any common multiple of those. So we can either look for the lowest common multiple of 3 and 4, which is 12, or the lowest common multiple of 7 and 5, which will be 35. If we did that, we'd end up with much bigger numbers, but it would still work. So we're going to scale it up to make the x's the same. So we're going to multiply this first equation by 4 and this second equation throughout by 3, so that we have 12x in both sets of equations. Now we have 12x in both, we can see 12x plus 28y is 180 and 12x plus 15y is 141. They both have the same 12x, so actually if we subtract one from the other, 12x take away 12x is nothing. They disappear. 12x minus 12x disappears. We have eliminated the x. 28y minus 15y is 13y, and 180 minus 141 is 39. And you can see what we've managed to do now is get rid of the x's, so we have a single equation in one variable, y. If 13y is 39, then y is 39 divided by 13, which is of course 3. Let's use that information and substitute it into either of the equations. Let's use the second one. So if 4x plus 5y is 47, and we know that y is 3, then 5y would be 15. 4x plus 15 is 47, so 4x is 47 minus 15, which is of course 32. So x is 32 divided by 4, which is 8. So the solution is x equals 8, y equals 3. We can check that it's right by substituting it back into the first equation. 3x plus 7y needs to equal 45. Well, is that the case? Well, if x is 8, then 3x is 24, and if y is 3, then 7y is 21, and of course 24 plus 21 does indeed equal 45, so this is the correct solution. Okay, now I hope you understand what the process is. We need to find a number to scale both equations up by so that we have either the same number of a's in each or the same number of b's in each. The lowest common multiple of 7 and 11 is 77, which would mean multiplying one equation by 11 and the other one by 7, which would absolutely work and be true, but the numbers get a little bit unmanageable. Whereas if we looked at the b's instead, the lowest common multiple of 2 and 5 is 10, which is quite a bit easier. We'll multiply this first equation by 5 and this second equation by 2. What do we get? Well, if we multiply the first by 5, 5 times 7a is going to be 35a, and 5 times 2b we already know is going to be 10b, and 5 times 26 is 130. If we double the second equation, we'll have 22a plus 10b equals 78. If we subtract the two equations now, 35a minus 22a will leave 13a. The 10b take away 10b will disappear, will be nothing, and 130 take away 78 will be 52. So we have 13a equals 52, so a is 52 divided by 13, which is 4. So let's substitute that into the first equation. Looks a little bit easier. 7a plus 2b equals 26. Well, if a is 4, then 7a is 28. 28 plus 2b is 26. I don't want 28 plus 2b, I want to isolate b, so let's get rid of it first. So 2b equals 26 minus 28, so 2b is minus 2, so b is minus 1. So the solution appears to be a equals 4, b equals minus 1. Let's check with the second equation just to be sure. If a is 4, then 11a is 44. If b is minus 1, then 5b is minus 5. And 44 plus negative 5 does indeed equal 39. So the solution is a equals 4, b equals minus 1. Now, in this fourth example, we need to be a little bit careful. It is not always the case that we need to subtract. If we did subtract, then we would have 3a take away 7a is minus 4a. But then here we need to be really careful. Minus 2b subtract 2b is actually minus 4b. So subtraction does not eliminate the variable in this case. Instead, what we need to actually do is add them together. 3a plus 7a is 10a, and then minus 2b plus 2b is actually 0. Minus 2b plus 2b offset each other and disappear. And then finally 17 plus 73 is 90. So here we have 10a equals 90, so clearly a equals 9. If a equals 9, let's put it in this first equation. 3a minus 2b equals 17. If a equals 9, then 3a is 27. So add 2b to both sides. So we have 27 is 17 plus 2b. Take 17 off both sides. And we have 2b equals 10, so b equals 5. Solution is b equals 5 and a equals 9. Let's just check. With the second equation, if a is 9, then 7a is 63. If b is 5, then 2b is 10, and 63 plus 10 does indeed equal 73. So a equals 9, b equals 5. So the simple rule is to make sure we do the operation of subtraction or addition on the two equations so that one of the variables disappears. We eliminate one of the variables. The usual mnemonic, which is good to remember this, is same signs subtract and different signs add. Same signs subtract, different signs add. And this refers to the sign of the things that you have made the same. Here we have three examples of systems of equations where one of the variables is already being made to be the same. The thing we have to do is figure out whether we need to subtract or to add so that the variable that we've made to be the same disappears. We manage to eliminate one of them. So in this first example we have plus 13b and plus 13b. They have the same sign, so we need to subtract these two equations. 11a subtract 5a is 6a, 13b take away 13b disappears, and 24 minus 18 is 6, and we can go on from there. We've eliminated the b from the expression. In this second pair of equations we have minus 9q and plus 9q. These have different signs, so we need to add the two equations together. If we add them, 42 plus 17 is 59p, minus 9q plus 9q balances out and we're left with nothing, and 75 plus 43 is 118. So we've eliminated q from the expression. 59p is 118, so p is 118 divided by 59, which is 2, and we can solve it from there. And this last example, the thing which really matters is the thing we've made the same. It is about the 10x, not about the other sign. 10x in one equation and 10x in the other equation. They're both 10. It's not 10 and minus 10. They're both 10, same sign, so we need to subtract. 10x take away 10x disappears. Minus 15y subtract 2y is minus 17y, and 15 take away 32 is minus 17. So y is minus 17 divided by minus 17, which is 1. So again, the process is to determine whether we need to add or subtract the two expressions, and if they have the same sign for the thing you've made the same, then you subtract, and if they have different signs, then you add.